physics, and today we'll be starting a new chapter, that is work and energy. So with work and energy, as we discussed work and energy, first today we'll be only discussing about work, okay, how work is done, what is work done, different examples related to work done, and numericals related to it. So work done. When is a work said to be done? So you do anything when you lift a chair, when you push somebody, when you just lie down, you think you're doing work. When you're reading your books, when you're doing your assignments, you think you're doing work, isn't it? But in physics or in science, it has a different definition. Okay, and how is work done defined in physics? So in physics, work done is defined as something which, when applied, a force displaces the object. For example, when if I just pull this up, okay, it was lying over there and I just lifted it. So what am I doing? I'm doing a work. What work am I doing? I'm lifting this up. Now why is this considered to be work done, isn't it? So when it was lying down, it was not moving at all. So when I lifted it, what am I doing? I'm applying a force. I did apply some force, isn't it? Even if it's a small amount of force, I did apply some force, and when I lifted it, what happened? It changed its position from one place to another. So when there is a force applied on an object, displaces the object, which means if the object moves when a force is applied on the object, then we say the work is done. Okay. Otherwise, if you just lift a bag, you just hold a bag and just stand still. Okay, even if you stand still for 5 hours, 6 hours, work will not be considered to be done. Work is not said to be done then. Why? Because there is no displacement. You did apply force, you did apply the force of lifting the bag, but still there was no displacement. So if there is no displacement, no work will be done. So what is work done? Work done is defined as the force, when the force applied on the object displaces the object. Or in short, we say work done is a product of force and displacement. Okay, so work done is equals to F into D. This is your mathematical expression of work done. So what is work done? How is work is defined as? Work is done on an object when a force causes a displacement of the object. That means if the object does not move, no work will be done, no matter how much force you have applied. So all those physical, mental effort is not considered to be work done. You continue thinking, you just scratch your head to do some sum, until there's no displacement, no work will be done. You lie down, you read book, you finish the entire book, but still work will not be considered to be done because there is no displacement. Okay, so mental pressure or the mental work that we do, the mental exercise that we do is not considered to be work done in physics. Only the physical, that means when there is a displacement. So work is the product of the force applied on an object and the displacement of the object. Now some of the cases of the work done. See, when you lift this bucket up, what happens? You apply a force on this bucket and the bucket moves up. Okay, so in this case, the work will be done. Here, the coolie is carrying a luggage and is walking. In this case, the work will not be considered to be done. Why? Though he's applied force and the box is moving along with him, but the force applied here is perpendicular. Okay, it's in the perpendicular direction. So if the force is applied in the perpendicular direction of the surface, then the work will not consider to be done. Okay, you will be understanding this more in detail in higher classes. As of now, just understand, if the force applied is in the perpendicular direction of the force, then the work will not be considered to be done. So work depends upon two factors. One is force, the other is displacement. Okay. Now see here. If the lady is pushing something, so when the lady pushes something, the work is considered to be done. Here the lady is carrying a bag and just sitting. So here the work is not considered to be done. the lady is sitting down and standing up. So in this case, the walk will be considered to be done. If the person is holding the object and not moving at all, then the walk will not be done. Now see an example of uniform circular motion. The moon, when it revolves around the earth, will the walk considered to be done in this case? No, the walk will not consider to be done. Why? As you know, you discussed this in class 7 itself. What is displacement? Displacement is the shortest path traveled, isn't it? And if the object comes back to its initial position, then the displacement is considered to be 0. That means no displacement is taken place, isn't it? So here the moon, if it starts from here, it goes round the orbit and then comes back to its initial point. So when it comes back to its initial point, displacement is considered to be 0. If displacement is 0, then walk done will also be 0. So no walk is done by the moon on revolving around the earth. Similarly, earth revolving around the sun will not be considered to be walk done because it comes back to its initial point. And if it comes back to its initial point, displacement will be 0. That's why no walk is done. Now, we talk about the units of work done. Okay. So what are the different units of work done? As we discussed, work done is expressed as force into displacement. What is the unit of force? SI unit of force is Newton. And what is the SI unit of displacement? Meter. So Newton, meter, also known as Joule. Okay, the SI unit of work is Joule, named after the physics scientist James Prescott Joule. Okay, and symbolized with capital J. So what is the unit of work done? The SI unit of work done is Joule. And the smaller unit of work done will be erg, which is not mentioned over here and is not mentioned in your book also. There is another unit which is also called kgf. Okay, what is kgf? The full form of kgf is kilogram force. So when an object is displaced with the help of the gravitational force of the earth, then when the work done by the gravitational force of the earth, we refer the unit as kgf. So everything that is related to the gravitational force of the earth, work done by the gravitational force of the earth, then we say it to be kgf. And what is the relation between kgf and Newton? 1 kgf equals to 9.8 Newton or 10 Newton. Okay. Now, here is a numerical related to work done. Say the question says you are helping to push your mother's heavy shopping cart with a force of 50 Newton for 200 meter. That means what is the force applied by you? 50 Newton. And what is the displacement of the object? 200 meter. So what is the amount of work done? What is the formula? Work done is equal to force into displacement. What is the force given? 50 Newton. And what is the displacement? 200 meter. So when you multiply them, how much you get? 10,000 joules, which is also 10 kilojoules. A kilojoule is a higher unit. That means when you have a large amount of work done, so we use it as kilojoule. Okay, when you lift very heavy object, that means a lot of strength is applied, a lot of displacement takes place, then we use a larger unit of joule, which is kilojoule. So these are the various terms related to work done. So I hope you understood what is work done. A work is said to be done when a force applied on the object displaces the object, and the examples which are related to work done and work not done. So when you push a wall throughout the day, the wall will not move. In that case, the work will not consider to be done. Okay, but when you lift a bag and you walk around, when you lift a bag and you just travel to certain distance, the bag, you put effort on the bag, carrying the bag, and there is a displacement of the bag also. So in that case, work will be considered to be done. So, and also when it's a uniform circular motion, that means when the displacement will be 0, work will not be considered to be done. and the SI unit of work done is joule. Okay, and the smaller unit of work done is earth. And in the next class we will be discussing about energy. Okay, so today we have some numericals. You have some numericals in your copy textbook, which is related to work done. You have similar questions. Please do those questions. Okay, so we stop for here today. Thank you so much.